Okay, so today we're starting on page 106, and the title is Rational Expressions. Rational expressions. A rational expression is the quotient of two polynomials. So basically, when you're dividing one polynomial by another. It could also look like a fraction. A rational expression in simplest form I should have said a rational expression is in simplest form when its numerator and denominator are polynomials that have no common divisors. Also known as the factors. So today I'm going to teach you how to simplify a rational expression, how to multiply rational expressions, and how to divide rational expressions. So there's a lot going on, but basically if you can factor, then there's not a whole lot to learn. Okay, factoring is the biggest thing that you have to know when dealing with rational expressions. And we know how to factor really well because we've done it a lot, right? Okay, so my directions say simplify and state any restrictions. Restrictions are any numbers that would make the denominator a zero. Now, in my opinion, if any of you took the PERT, if you're wanting to take a collegiate class, math class, and you need, what, a 114, I believe? I know a lot of people took it and they weren't quite at a 114. If you take it again, especially after the last, the polynomials that we just did, and this next module that we're going to do, more than likely your grade should be high enough. Because this next lesson, I feel like there's a lot on the PERT about this module that we're going to do right now. Okay? Okay, so my example is x squared, bless you, plus 7x plus 10 divided by x squared minus 3x minus 10. Now, a lot of students see this and they just want to cancel things out like they see them. Okay, they want to like cancel the x squareds, cancel the 10s, cancel these x's. You can't do that. This quadratic all goes together. Okay, it's one polynomial. You just can't cancel out parts of it. You can only cancel out factors that are the same. Okay, so until that's completely factored, do not cancel anything. So basically, I'm going to factor anything that can be factored and cancel what I can, and what's left is your answer. Okay? So in my numerator, let's write a little note. Factor the numerator and denominator to see if there are any common factors. Factor the numerator and denominator to see if there are any common factors. So my numerator, it's a quadratic. I'm going to show my work over here on the side. So I'm going to use divide and slide to see if it can be factored. Is there a greatest common factor in my numerator? No. All right, so A is 1, B is 7, and C is 10. So we need two numbers that multiply together to give us A times C. In this case, that would be a positive 10. And two numbers that add together to give us B, which is a positive 7. All right, let's try it. 2 times 5 equals 10, and 2 plus 5 equals 7. So that's going to work. So my numerator's factors would be x plus 2 and x plus 5. All right, let's try to factor the denominator. So my denominator, A is 1, B is negative 3, and C is negative 10. We need two numbers that multiply together to give us A times C, which is a negative 10. And the same two numbers need to add together to give us B, which is negative 3. Negative 5 and positive 2. Negative 5 times positive 2 is negative 10. Negative 5 plus 2 is negative 3. So that works. So we've got x minus 5 and x plus 2. Now we know that 5 divided by 5 is 1. A million divided by a million is 1. X divided by x is 1. X plus 5 divided by x plus 5 is 1, right? So basically these x plus 5 divided by x minus 5, is that 1? No. You cannot cancel unless they are identical, okay? So x plus 5 and x minus 5 does not turn into a 1. But what about x plus 2 divided by x plus 2? Yeah, that is a 1. So we kind of say they cancel. It doesn't turn into a 0. But we don't need to write 1 times x plus 5 over 1 times x minus 5, right? So your answer will just be x plus 5 divided by x minus 5. And you can put those in parentheses. You don't have to. If you had another factor there, you would definitely want to put parentheses. But since they're just x plus 5 is the only factor in the numerator, x minus 5 is the only factor in the denominator, you don't have to put parentheses. Okay, so the direction said simplify and state any restrictions. This is as simple as you can get. You cannot cancel out these x's. You cannot cancel out the 5s. If you are tempted to do that, then just leave your answer in parentheses because it's all or nothing, all right? Because x plus 5 goes together. You can't just take parts of it. Does that make sense? That's what students tend to do the most, where they mess up. Now, for the restrictions are any numbers that would turn your denominator into 0. Look at your denominator before you canceled anything. So up here, what could I plug in for x to make this number minus 5 a 0? 5, right? 5 minus 5 is 0. So x cannot equal 5. And over here, what would I plug in for x to turn negative 2, right? So x cannot equal 5 and x cannot equal negative 2. Because if it was either one of these, at 5 or negative 2, it would turn your denominator into 0, and you know that you can't have 0 in the denominator. So that's all that restrictions mean. Just make sure you pick your restrictions before anything's canceled out. Coolio? Any questions? All right, page 107. I'm going to simplify again. This time we have 24 x cubed y squared over, or I should say divided by, negative 6x squared y cubed. Now this would be something probably that you learned how to simplify in Algebra 1, hopefully. This shouldn't be anything new. Now 24x cubed y squared, how many terms is that? How many terms is the numerator?
One.
Just one term, okay? Because remember, a term or a monomial is a product, right? It can just be a number, it can just be a variable, or it can be a product of a number of variables. So since all of this is multiplied together, that's just one term. Same thing with the denominator. That's a product. Negative 6 is being multiplied by x squared is being multiplied by y cubed. So when you just have a monomial divided by a monomial, you can just reduce certain things within there. It doesn't have to be all or nothing. Okay? Before, these are binomials. So if you have a binomial, it can only be reduced with another binomial that's identical to it. Okay? So I can just reduce this. So 24 divided by negative 6 is what? Negative 4, and that would be in the numerator. X cubed divided by x squared. Y'all remember your rules when you divide and you have like bases? Just the x, right? Would that be in the numerator or the denominator? Numerator, because you have more x's in the numerator than you do in the denominator. Think about it like this. X cubed means x times x times x. X squared means x times x. So when you cancel out the like factors, you have one x left and it's in the numerator. Okay? Y squared divided by y cubed. Y. And is it going to be in the numerator or the denominator? Denominator. Because I have more y's in the denominator than I have in the numerator. So that's simplified. That's all you can do. Now, it said state the restrictions. I've got two variables here. So you can see, what would x have to be to turn this all into a 0? 0, right? So x can't be 0. And then also you have another variable of y. What would y have to be to turn the denominator into a 0? Oh, 0 again, right? So x can't be 0 and y can't be 0. And that's that. (12 minus 4x divided by x squared minus 9). Now for my numerator, 12 minus 4x, it's not in standard form. So before you factor it, so that you don't confuse yourself, put it in standard form first, which would be what? Good job. So happy you didn't say 4x minus 12, because the 12 is not negative, right? The negative 4x, or the 4x is negative. And then I'll just factor them both at the same time. I just wanted to rewrite that in standard form. Okay, so my numerator is not a quadratic polynomial, so I can't use the T-chart dividing slide, right? It's just linear. And the only thing you can do to a linear polynomial is factor out a GCF if there is one. If not, there's nothing you can do. So, is there a GCF?
Yes.
What is it? It's 4, and then yes, because the leading coefficient is negative, we don't want that, so we're going to divide out a negative 4, right? So negative 4 is my GCF. If I factor that out, what would be left?
X plus 3.
X
Minus 3.
-3. Does anybody notice that the denominator is a special case? What is that? Difference of two squares, very good. So it's a lot easier to factor than the difference of cubes, right? Remember, perfect square minus a perfect square. To factor it, two sets of parentheses. One of them gets a plus sign in the middle. One of them gets a minus sign in the middle. The first term in each set of parentheses is the square root of the first term. So that will be x. And the second term is the square root of the second term, 3. Can I reduce anywhere? Yes. The x minus 3 and the x minus 3 reduces. So you're left with negative 4 divided by x plus 3. And that's all you can do. So what are your restrictions going to be? X cannot equal positive 3 or negative 3. You just look at your denominator. And remember, look at it before you reduce anything. So it can't be a negative 3 because of this factor. It can't be a positive 3 because of this factor. And that's all you can do. Anybody have a question? Okay. Now let's multiply. All right, we're going to find the product, which obviously means multiply, of x squared plus x plus u minus 6 divided by x minus 5 times x squared minus 25 divided by x squared plus 4x plus 3. Now remember, when you multiply fractions, numerator times numerator, denominator times denominator. So what I like to do is just first factor everything out, okay? And this does take a lot of room because you got to factor everything. So it doesn't matter where you start. I'll just do x squared plus x minus 6. And I'm going to write down in my notes what I'm working with, so when you look back at your notes, you know where I got what. So here a is 1, b is 1, c is negative 6. Two numbers that multiply together to give you AC would be a negative 6. And two numbers that add together to give you B is positive 1. What you think? What you think? 3 and negative 2? 3 times negative 2 is negative 6, and 3 plus negative 2 is positive 1. Perfect. So this numerator will be x plus 3 and x minus 2. Can I factor x minus 5? No. It's a linear polynomial. The only way to factor a linear polynomial is if there's a GCF. There's not one. So x minus 5 can't be factored. Saved us a little bit of work. What about x squared minus 25? What's that? Difference of two squares, right? So we can factor that easy. We don't even need to do a t-chart divide and slide. You could. A would be 1, B would be 0, and C would be negative 25. But we can recognize it's a difference of two squares. So we know that's going to be x plus 5 and x minus 5, right? And then I'll need to factor x squared plus 4x plus 3. A is 1, B is 4, C is 3. Remember, all of these seem to so far have had A was 1, so if it's not, remember you got to make sure you do the divide and slide part. So we need two numbers that multiply together to give us A times C, which is a positive 3, and add to give us B, which is positive 4. 1 times 3 is 3, 1 plus 3 is 4, so that works. So those factors are x plus 1 and x plus 3. Now, in my homework, I wouldn't do this next step, but I want to show you why we do what we do. Remember, when you multiply fractions, you do numerator times numerator. So technically, we're multiplying x plus 3 times x minus 2 times x plus 5 times x minus 5, right? All over denominator times denominator. X minus 5 times x plus 1 times x plus 3. And the reason I'm doing that is to show you that I can cancel out a factor from that second fraction with a factor from the first fraction, as long as one's in the numerator and one's in the denominator, okay? Say that I had this x minus 5 here, and say I had two x minus 5s on the bottom. You can only cancel one from the top, one from the bottom, okay? That one from the top can't cancel two different factors in the bottom. So be careful about that. So the only thing that cancels here, x plus 3 divided by x plus 3 is 1. X minus 5 divided by x minus 5 is 1. Nothing else cancels. So in my numerator, I'm left with x minus 2 times x plus 5 over x plus 1. There's nothing else I can do. You may see them multiply that out and put it back in standard form. I'll have to check in the workbook to see how they leave the answers, but I think they just leave it factored form. But we know how to put that in standard form if we had to, right? Once you put it in standard form, remember, don't cancel out just pieces. All factors or all or nothing. So my restrictions, x cannot equal, remember, go back up to your denominator before you canceled anything. So x cannot equal a negative 3, right? Because negative 3 plus 3 is 0, so it can't equal negative 3. It can't equal negative 1, and it can't equal positive 5. If you get confused, just think about set that equal to 0 and solve for x. That's all you're doing.
It's only the denominator?
In the denominator only. Because it's okay if your numerator is a 0, right? When you divide, if your numerator is a 0, it's a 0. But if your denominator is 0, that's undefined. You can't do that. So that's why we have to state the restrictions. Okay, let's do one more multiplication, and then we'll do division. And division's exactly the same except for that one thing. Remember, when you divide two fractions, keep the first fraction, change division to multiplication, and then you do the reciprocal of the second fraction, right? Keep, change, flip, you may have learned. But that's not proper math words, so keep the first fraction, multiply by the reciprocal. But we're not doing that yet. We're still doing one more multiplication problem. We have 2x minus 8 divided by x squared minus 16 times x squared plus 5x plus 4 all over x squared plus 8x plus 16. All right, 2x minus 8. What am I going to do with that? GCF. And that's it, because it's linear. And is there a GCF? 2. If I factor it out, what's left? X minus 4. And y'all know all I'm doing is dividing both terms by the GCF, and that's how I get what's left in parentheses. X squared minus 16, what's that? Difference of two squares. So we know one set of parentheses will have a plus, one will have a minus. The first term is the square root of the first term, so that would be x. The second term is the square root of the second term, so that would be 4. Times x squared plus 5x plus 4. That's a quadratic polynomial, so I will use T-chart and divide and slide. Is there a GCF? No. So A is 1, B is 5, C is 4. We need two numbers that multiply together to give us A times C, so that's positive 4, and add to give us B, which is a positive 5. There we go. Positive 1 times positive 4 is 4, and 1 plus 4 is 5. So x plus 1 and x plus 4. The denominator, x squared plus 8x plus 16. Again, we have a quadratic. Does it have a GCF? No. So T-chart divide and slide. A is 1, B is 8, C is 16. Two numbers that multiply together to give me A times C, being positive 16, and that add together to give me B, which is a positive 8. 4 times 4 is 16. 4 plus 4 is 8. Boom. So x plus 4 and x plus 4. So in the last example, I rewrote the problem and put everything in the denominator all together and everything in the numerator all together, right? Like I said, in my homework, I wouldn't go through that. I just want to show you that I can cancel something from this fraction with something from this fraction, okay? So x plus 4 and x plus 4, or I could cancel this one over here. It doesn't matter, but just one of them. I would need another x plus 4 in the numerator to cancel another x plus 4, which I don't have. X minus 4 and x minus 4. Can I cancel these two x plus 4s? No, because they're both in the denominator. That does not cancel. You multiply those. Yes?
If, like, one of those x's was x minus 4, could you do it again because of the 2? Or no? Because, you know, like, before we factored it, it was... No.
I'm not sure what you're saying.
Okay, so, like, if the x plus 4 was x minus 4, does the 2 in front of the parentheses for x minus 4 mean that we could cross out 2
No.
x minus 4?
No.
Okay.
Mm-mm. No. If that was squared, that would mean there were two x minus 4s.
You're right.
But that 2, no, that you can't do that.
Okay.
Okay? All right, is there anything else I can cancel? Am I missing anything? No. Okay. So my numerator, I have 2 times x plus 1. Again, you may see that multiplied out in standard form. You may just see it factored. And in the denominator, I have x plus 4 times x plus 4. So I'm just going to write x plus 4 quantity squared. Bless you. And there's nothing else I can do. Okay? Unless you just multiplied it all out and put it in standard form. Restrictions, x cannot equal. Go back up here before we reduce. So x cannot equal 4 or negative 4. Yeah, positive 4 or negative 4. Because here, negative 4 plus 4 would be 0. Here, positive 4 minus 4 would be 0. Negative 4 plus 4 would be 0. Negative 4 plus 4 is 0. You don't have to list it multiple times when you have the same fraction. Okay, just list it once. Any questions on that? Every time I say any questions on that, I want to say, how about Dad? But I won't, just that one time. All right, now we're going to divide rational expressions. Two minus x. Divided by x squared plus 2x plus 1. Divided by x squared plus 3x minus 10. Divided by x squared minus 1. Now to start this off, you may choose to start by factoring everything first. But, in my experience, when kids do that, they forget that whole keep, change, flip thing. Okay? They get stuck in the factoring, and they forget that they never changed it to a multiplication problem. Just like with regular fractions. When you divide, you have to change it to multiplication, right? So you keep the first fraction the way it is, change division sign to multiplication, and do the reciprocal of the second fraction. Remember that? From like 3rd grade? I call it keep, change, flip. So I do that first and then I factor. Otherwise, I'll forget that I never did that to begin with. Okay? So, keep the first fraction the way it is. Change the division to multiplication. And write the reciprocal of the second fraction. And now it's just like it was when it was a multiplication problem. So for 2 minus x, what am I going to do with that?
Nothing.
There's nothing I can do to factor it, but
Switch it to negative x plus 2.
exactly, I'm going to switch that. I'm going to put it in standard form, negative x plus 2. And then in my next step, I'm going to factor out a negative 1 because if this was x minus 2, I may be able to change it with something. But probably I'm not going to get a negative x plus 2 as a factor, okay? So I want to divide out that negative 1, but I'll do it in my next step. Okay, for x squared plus 2x plus 1, I'll do that over here on the side. It's a quadratic. There's no GCF. So a is 1, b is 2, c is 1. Two numbers multiply together to give me AC, which is a positive 1. And two numbers that add together to give me b, which is a positive 2. 1 times 1 is 1. 1 plus 1 is 2. So that's x plus 1 times x plus 1. I'm going to write it out this time until I cancel. For x squared minus 1, what is that? Difference of two squares, right? Perfect square minus a perfect square. So 2 sets of parentheses. One will get a plus, one will get a minus. The first term is the square root of the first term. The last term is the square root of the last term. And then x squared plus 3x minus 10. Again, there's not a greatest common factor. So a is 1, b is 3, c is negative 10. Two numbers multiply together to give me a times c. And then add together to give me 3. So multiply to get negative 10, add to get 3.
5 times negative 2.
5 times negative 2 is negative 10. And 5 plus negative 2 is 3. Perfect. So we have x plus 5 and x minus 2. Okay, so now I'm going to have to rewrite this whole thing because of this one little factor right here. Probably y'all draw a line through it and just do it above, but that is not how I roll. So if I factor out a negative 1, what am I left with? From negative x plus 2. X minus 2. And everything else is already completely factored, so I'm just going to rewrite it. Then I reduce like factors where I can. So see, if I left that as negative x plus 2, I would not realize that I could reduce it with x minus 2 over here. Because those are not identical, so they would not have reduced. But since I factored out that negative 1, that gave me a like factor that I could reduce. I can reduce x plus 1 and x plus 1. Am I missing anything am I not seeing anything that I can reduce? No, I don't think so. So in my numerator, I have negative, I don't have to put that negative 1, it'll just be implied, times of x minus 1, all over x plus 1 times x plus 5. My restrictions, x cannot equal a negative 1, a negative 5, or a positive 2. Also, this gets a little confusing on division because you have to look at the factors that were ever in the denominator. Okay? So up here, this x squared plus 3, this x squared minus 1 was at one time in the denominator, okay? So factored, that was x plus 1 and x minus 1. So we have to take that into consideration as well. So the negative 1 we already have listed here, but we would need a positive 1 as well. And I know that gets confusing on the division. Anytime you had a factor in the denominator, you have to look at that and state what the restriction would have been while it was in the denominator. Okay? One more, then we're out. Page 109. Y'all want to try this one on your own? Is it complicated? It's just a bunch of factoring. You think it is complicated? Why does everything have to be so complicated? Here? Yeah. Okay, so I'm dividing two rational expressions. Factor them to start with if you want, but I do not advise it. I would start by doing the whole keep, change, flip thing. So I'll keep the first fraction the way it is. Change your division to multiplication and write the reciprocal of the second fraction. See, am I confused so far? Don't do that when you're multiplying. You only do that for dividing fractions, right? Okay, so it looks like pretty much everything has to be factored. I'll start with x squared plus 5x plus 4. There is not a GCF. I need two numbers that multiply to get positive 4 and then add to get positive 5. 4 times 1 is 4. 4 plus 1 is 5. So that's x plus 4 and x plus 1. Now I will factor x squared plus x minus 12. There's not a GCF, so I'll go ahead and do my T-chart. Two numbers that multiply together to give me negative 12 and add to give me positive 1. 4 times negative 3 is negative 12, and 4 plus negative 3 is positive 1. So x plus 4 and x minus 3. My numerator over here, 2x squared minus 6x, it is a quadratic, but I see it's a quadratic binomial. We would still do a T-chart on that, but first, is there a GCF? What is it? 2x. So if I factor out the 2x, what's left? X minus 3. So now we're not going to do a T-chart because we have two linear factors, and you can't do T-chart on linear factors, right? So this is completely factored. 2x times x minus 3. For x squared minus 1, that's a difference of 2 squares. We get one gets a positive, one set gets a negative, and that'll be x plus 1 and x minus 1. Okay. Let's see. We can x plus 4 and x plus 4 will reduce. X plus 1 and x plus 1 will reduce. X minus 3 and x minus 3 will reduce. And so I'm left with 2x divided by x minus 1. My restrictions, x cannot equal from this factor a negative 4, a positive 3, a negative 1, a positive 1, and remember 2x squared minus 6x was originally in the denominator, so it can't be a 0 or a positive 3, but we already have that listed. Anything else we can do? And that's that. Anybody have questions? Comments? Concerns? All right, get out your workbooks. Let's do some problems on your own.